I'm Frédéric Dolomez, and I will do a quick tour of our demonstrations, latest innovation we are showcasing here. Let's start with the artificial intelligence, where we are showcasing some nice applications running on our STM32 MCU.
ST has a big role to play in the mobile world, right?
A big role, and a lot of building blocks are coming from ST microelectronics for any IoT devices. And this is one of the key blocks we are showcasing today.
So this is right here, this like an AI IoT device right here.
Yes, here we have handwriting character recognition, which has been ported directly on our L5 microcontroller. So if we write S, T, it recognizes the letters.
Nice.
TA.
So there's actually AI on microcontrollers. It's
Yes.
a big deal for ST to have this, right?
It's a big deal to be able to port the artificial intelligence neural network into a small and compact MCU to be able to have AI on any kind of MCU.
And this one is also AI, right here, the
It's
demo.
food classification demonstration running also on our MCU.
Nice. And what kind of other things do you have around here?
So moving to the sensor part with our imaging, brand new sensors, photonic sensors, and also ambient light sensing. I will let Ken comment about that.
Hi, so who are you?
Hi, I'm Ken. I'm from the Imaging Division based in Edinburgh, the UK, where we one of the big sites where we make our time-of-flight sensors. And what I'm demoing here is the latest generation, where we actually have an 8x8 array. Now each of the numbers that you can see on the screen is actually representing a range in centimeters. So you can see that we're now starting to build up quite a nice three-dimensional understanding of what the scene looks like. So this could be used for touch to focus, for example, with a camera system and a phone, and even start to build up a simple depth map of the scene as
So
well.
is this the resolution?
The resolution is 8x8, and the range that you can see, the number that you can see in each of the zones, is the centimeter distance that the target is from our device.
What happens if you go over there? Can you
So
go
if I go
far?
over there, so the maximum range will depend somewhat on the target that it's looking at. You can see we're ranging that gentleman there up to almost 2 meters. If the light level comes down, we can range further. Or if the target as
Light level?
the light level, if the light level is lower, we'll range further.
Ah, so less light is go further.
It's good for us, yeah, correct. Because remember, within our device, we have a light source, which is a 940 nanometer laser, and then we have the array of light sensing diodes. Both of these elements, both the laser and the array, are lensed, so they're very good at capturing
you have it in the
light.
back too?
Yeah, so we've got one mounted here. This is just a demo platform.
Back and front.
Back and front, yeah.
How do you connect them to the tablet?
It's coming in through USB. We have an ST microprocessor as the
And then
as the
it's
host.
just a USB host to your little laser system.
Correct.
And this is being adopted already?
So this particular one is yet to enter mass production, but the previous generation, where we're only able to range for one zone, has been in over 100 million phones already worldwide. So it's,
100 million
it's a big
phones.
success. Yeah.
And it's called time of flight.
Time of flight is the underlying technology, but the key application, the key use case that we've had best success with is what we call laser autofocus, where we're using the range that we return on the target to help the camera system focus faster and more accurately. And we hope that
So
this
you're
device
basically
will
helping the
carry on that.
contrast-based autofocus
Correct,
this way.
correct.
You're
So-
speeding it up.
So we're essentially another element of a hybrid autofocus system. That's
It's
right.
not phase detect.
Different from phase
It's
detect.
not dual pixel.
No.
It's laser
Correct.
autofocus.
But it's in addition to, so where the phase detect data is less reliable, where the contrast data is less reliable, we can help with our exact range on the target. So they can all work in conjunction with each other.
Is there any chance this kind of stuff could do like the same resolution as the actual the photo?
I think
Do
that-
every single pixel.
That could happen. I think the natural thing, and in fact we have a roadmap to higher resolution parts over the next couple of years.
And
so yes.
for this to happen, you need the laser. You can't just do it with a light that's there.
You need to have an underlying light source, that's correct.
You
yeah.
need to illuminate it.
Yes,
So
correct.
it's like
So it's you've already seen it, for example, inside some of the iPhone family with the structured light solution
With
on the front
infrared.
of, and it's also operating in the infrared. Yes,
that's
right.
different.
It's slightly different technology, but working at the same wavelength. Yeah, we're working at 940 nanometers. I should say, although although we've used the word laser, it's of course all eye safe, it's all class 1, so no problem with damage to the human eye.
Is there any chance this can go to a very long distance?
Well, that's a good question. I think for this type of technology, yes, you can, and you'll start to see systems on cars for self-driving called LiDAR, which is much longer range, where you may operate up to 150, 200 meters.
This LiDAR is different tech,
But
right?
fundamentally, the underlying technology is very similar, but just implemented in a slightly different way. Yeah.
Cool. All right. Thanks a lot.
Okay.
Thanks.
Welcome.
All right.
Okay, let's
So
move.
this is a big deal for the ST?
It's one of the big deal for ST. Another brand new product is the ILS sensing sensors we recently announced last week.
And it combines 3-in-1 functionalities. The first one is color sensing, RGB, IR. It also combines ultraviolet sensing, UV, UVA, and last but not least, it's also a flicker engine that is able to extract the light frequency to get rid of the banding effect on the image.
So there on the desktop, you had the actual chip,
Yeah,
and it's why did I see those lights? Can you show it again?
sure.
What is this?
Those are the colored photodiode in the circuit. So
And
this
they
is
colored. They each have different color.
Yeah, correct. That's
you
the
look at it?
active array of the circuit. So we have several photodiodes that are colored with some color filters, RGB, UV, and infrared to sense light and provide the information to the system.
And what happens when you? What were you showing?
So right there, this demonstration is what happens with all recent smartphones in the market. So the light in your home are usually flicking. Your usual tungsten, neon, and fluorescent light are usually 50 and 60 hertz. But with the modern lighting, LEDs are flicking at total unknown frequencies that can go up to 1 kilohertz. So that's a total headache and a challenge for all camera systems today. And what our sensor is providing is the actual frequency of the light system flicking. We can compensate with some algorithms and find the right exposure time for the camera to get rid of the banding effect on the image.
How do you do that?
So the flicker,
What does it have to do with the color sensor?
it's a 2-in-1 product, so we are able to assist the camera for not only the camera, let's say white balance, with RGB color tone tuning, but also we correct the banding effect on the image. That's a 2-in-1 product, and that's the key differentiating factor in the market. So first step is to set the right exposure time with the camera to avoid the banding. And in the second stage, we adjust the color rendering. If it's a yellow, bluish color, you can compensate with true tone color sensing with the product.
And this is 2-in-1 in this tiny little chip. And what do other people do? They only do it in software, or?
So usually competition is only able to perform white balancing with conventional RGB, let's say, filters. It's not fully accurate because you still miss the ultraviolet information. UV information is useful to indicate if you are indoor or outdoor in the scene. It provides you artificial light or natural light information.
All right.
Okay?
So this is a big deal for the smartphone industry.
Yes, indeed. The camera system complexity is increasing in the market. When you look at Samsung, Huawei, or all Chinese phones, the number of cameras becomes now 2, 3, 4 times bigger than before.
And you connected by Type-C or your sensor? Or is it part of the phone?
Here we put the sensor, we just connect the sensor with USB as a proof of concept to adjust the white balance of the camera and also the flicker banding effect to correct and get rid of the bounce on the image. Yes.
And this color, what do you call it, color sensor is important for photography or for what?
Main application of the color sensor is to help the camera system to provide a true tone and accurate color to the end user.
So auto white balance.
Auto white balance and also good videos without banding effect, whatever the circumstance. Without flicker effect and banding effect to avoid any blur image or bending on the picture.
Nice.
And on top, you can also integrate the sensor behind the glass because it's very high sensitivity product, and you can afford to have this kind of cover glass backside that is almost opaque.
Nice.
So if you put that here, you can still correct.
So having that sensor, the photos and videos are going to be better.
Yes, definitely. It improves user experience for everyday life. Whatever the use case, front integration or rear integration into the phone, that's really a breakthrough application.
All right. Thanks a lot.
Thank you.
All right. That was cool.
Okay. So let's continue the tour. So here we have some demonstrations from partners using our sensor and actuator product. Then this is one of the stars you will see also at Embedded World, the new STM32 MPU, MP1, that is combining a Cortex-M and a Cortex-A. So it's a brand new product from ST, and we are really proud of this integration. Double Cortex-A and Cortex-M integrated into a single chip. And so now we have an Open Linux and a full ecosystem on top of the STM32 ecosystem. This is a great news. This is a 60 GHz RF transceiver. It will be good for smartphones to have some high bandwidth transmission between two devices. I think we can go back to that demonstration quickly.
Right after?
Yes. Let's go. Sorry.
Let's go this way around.
Sorry.
Some mesh
We have a
and
collection
cellular.
of demonstration related to connectivity.
Yeah.
So with Bluetooth mesh, thread mesh. Moving there, we have LoRa and Sigfox connectivity also running on our STM32 boards.
Yeah.
Then here we have the NFC reader for payment application. That is also a product that has been recently announced.
Nice.
And we'll move to the security part.
Should we take this one?
We'll check. Oh, he is here. So Philip, if you want to introduce the product.
Yes, hello. So here we introduce ST25R3916, which is our latest NFC front-end chip. The demo of the purpose is to show you a payment.
Yeah.
So with this chip, you can have a look. That's
So what did you use there?
it is my banking card.
Your real one?
Yes, a real one.
And so it's just using the standard system of contactless.
Yes.
And what's special about this?
There is a new specification, the EMV Eurocard Mastercard Visa 3.0 specification, and this chip and this board is certified EMV code 3.0. We have passed the test in the laboratory.
EMVCO. What is
yes.
EMVCO?
EMVCO is a specification required for the contactless reader embedded in the POS and MPOS.
So anybody else have this solution, or is brand new?
All the new MPOS have to be in the coming months. All the new MPOS put on the market have to be EMVCO 2.0 compliant.
So it's increasing the security, or
Increasing the capability to make very nice contactless payments.
all right, cool. All right, thanks a lot.
Thank you very
Thank
much.
you.
Let's continue. Yeah. Let's move to one of the big move also in the smartphone industry. That is the embedded SIM.
Yeah.
And I will let Anne-Laure present the demonstration.
All right. Hello.
Hello,
Hi. So who are you?
I'm Anne Sixou. I'm working for Secure Microcontroller Division, and I'm responsible of the general communication for this division.
And here you have a new solution for eSIM, right?
Yeah, it's the
This is
main-
a big deal for the future of the smartphone
Yes,
industry.
it's a big deal, but the main message and the main important message that we reach and we exceed 1 billion units for the advanced secure microcontroller ST33.
So can you come a little closer to the mic? So you said 1 billion ST33?
More than 1 billion units for ST33.
What is that? So it's
ST
already over there in the market?
This is the secure microcontroller, and the importance of the secure microcontroller is that it's been designed to fit with all the security requirements for all the security applications, such as SIM or eSIM, embedded secure element, but also automotive M2M or TPM. And one of the main markets is the SIM and eSIM, and the deployment and eSIM, embedded SIM.
So do you provide the best eSIM solution on the market?
Sure.
Are you the market leader for eSIM?
We are the market leader for the eSIM, and we reach more than 100 million units on the eSIM. This is the future of the SIM connection.
And it's very easy to use? I haven't tried it yet, so it's just no need to a SIM card.
No need a SIM card. You can use the SIM card, but you can use also an eSIM.
Nice. That's very cool. But usually when devices have eSIM, sometimes they remove the second SIM card. Is it important to only have...
The difference between SIM and eSIM that the eSIM can manage the switch between all the MNOs. With the SIM, we are connected with a specific MNOs. With an eSIM, we can move from one to another MNOs. It's really a great advancement for the user, the final user.
But it's connected physically to the modem.
Yes, it's directly soldered on the PCB of the device.
And an eSIM is flexible to get any SIM information in.
Yes, the eSIM in fact is configured thanks to the remote system and a specific platform.
And is eSIM 100% secure?
Sure.
Impossible to hack this eSIM system?
It's the secure element.
Is the
secure element like a classical? Is the really secure element, and it fits with the last generation of security feature we embedded to fit with all the last generation of attacks.
Is it possible to upgrade the eSIM systems, or are they just secure forever, never need to update it?
You know that the security is not great forever. Then you have to evaluate with the attacks. Then the eSIM, the next generation of the eSIM will be designed by our fab. Then we will embed another generation in the next year.
All right, cool. Thanks a lot. Thanks. All right.
Should we check over here also?
Yeah, let's continue. Here we have a demonstration on the imaging as well, but this time on the automotive world.
So in-vehicle...
Where we have in-vehicle monitoring, so for driver monitoring, so powered by our imaging sensor.
Yes.
And let's move to the other demonstration. With telematics and GNSS, and I will let Pascal present that demo.
Cool. All right.
Hello. Are you on?
Hi, so who are you?
Hello, my name is Pascal Avillon from ST Microelectronics.
Yeah.
I'm here to present MTP. So MTP stands for Modular Telematics Platform. So what it is, basically, it's a set of modules, connectivity modules, LTE, Wi-Fi, Bluetooth Low Energy.
This goes in the car?
Yeah, this is a pre-development platform. So it's
that would be the main brain of the car, or what is this?
That's the brain of the connected car. So it's where all the communication is taking place over all those wireless and wired connectivity standards. CAN, Ethernet, FlexRay, that's wired. Wireless with LTE, Wi-Fi, Bluetooth Low Energy. Also positioning, we have precise positioning.
And this CAN technology and all that is very old technology in the car industry, right? But it's not very secure, and you want to make it more secure, or what are you doing here?
Yeah, exactly. So on this development environment called MTP, we have attracted, working on the Telemacro 3P, that is a security processor here, we have attracted an ecosystem of partners, also security companies such as Caramba Security, Argus, and also Ubiquiti for the software update over the year. So those companies are porting their solutions, security solutions, on Telemacro 3P. And we deliver to the market this solution that is pre-integrated, fully working, and we have customers such as Ficosa, and they have used this platform in the development of their CarCom platform.
This is a real product that goes in a real car?
It is a real product that is going to a car, and they have been using the same philosophy based on Telemacro 3P. They're using what we did there on the MTP, and then they have used some of the modules are the same, some of the other modules are something different targeted to their applications.
So when you say Telemaco GP, which part is that?
So Telemaco GP is here in the middle. This is the processor, it's the security processor.
Which one is that? Is it running an ARM Cortex something?
Yeah, so
Cortex A?
It's a Cortex A7 double core, dual core, and there is a Cortex M3.
So this is the new STM32MP?
No,
what do you call it? Or is it not?
It is Telemaco is a family of processor dedicated for automotive, created for automotive with high robustness to high temperature, also for safety relevant system ASIL-B, and dedicated around a very strong security core with an HSM. So the HSM is the key element here of Telemaco 3P, and that's why also all those partners have been attracted to work with us on security.
What's the HSM?
HSM stands for Hardware Security Module.
And you're showing some kind of, what are you doing here? Hacking it?
Yeah, so this is what we are developing together with Caramba Security. So Caramba is a security expert company, and we are working together here on a security system to protect the Linux application space in the Cortex A7. So what I'm doing here on this PC, so I'm connected, so here this is a debug console connected to the processor, and I'm going to attack. Okay?
You attack.
I'm going to attack the processor. So first, I'm doing, the security is implemented. The Caramba car wall application here is implemented on Telemaco. So I will attack a system that is already protected, and this is what's going to happen. So I'm trying to break in the system and send an exploit. So injecting the exploit, and it doesn't work. Why? Because it's protected by car wall. So now I'm doing the same, exactly the same, but using a port that is on purpose, not protected. So this is what's going to happen. I'm attacking this other port. Again, I'm trying to take control of the machine, of this Linux machine here. And what we normally will see, okay, it succeeded to get the rootkit. So now, using these things, so I'm connected over Ethernet, so using the network, I can manipulate this system that is the car actually. So here, this is a Windows laptop, but I manage the rootkit. So I have the full system. This is Linux, and this is Linux is running here. So I managed to take control of this computer in the car, and I can do all nonsense that I want. So for example, so we have a little application running here on Telemaco, that is an attack. So, and I'm doing an attack on the vehicle.
Doors are open.
Which is doing...
You owned, or what does it say?
It says airbag deployed, speed exceeded, and the doors are open. So it's really what you don't want to happen when you are driving a car. And here we are able to hack the vehicle completely. This is when the Caramba car wall is not active.
Is this groundbreaking, very revolutionary for the auto market? Nobody has this.
Nobody has such a wide ecosystem of security on a single platform. With Argus providing the intrusion detection, with Caramba Security providing car wall, and with all the hardware mechanism implemented in Telemaco 3P, such as isolation with several cores, such as the HSM, secure boot, and also TEE for Linux. So nobody has such a strong security architecture on the automotive processor.
Cool. All right. Thanks a lot. Cool. And
So this is closing the tour. I hope you enjoyed.
that was great.
And see you next year for the next edition of Mobile World Congress.
So ST is big in the embedded world, but also big in the mobile world.
We are everywhere, and we are covering markets like industrial, automotive, consumer market. So that's why we are everywhere. Yeah.
And this is one of the demos that kind of shows all the different stuff you're doing, right?
Yes, exactly. It's our interactive table that allows us to show that we are covering a lot of industrial applications. A lot of...
Trying to have an overview of ST is a big challenge.
Sorry?
That's why you have a nice
exactly.
way to see all the different things.
All the different things we have, and you can see more at Embedded World that is happening at the same time. So
okay, let's
have a look
go.
also.
I'm going there. Okay.